Hey everybody, this is Larry. This is me going with Q3. Wrong fingers. A lot of things wrong with today. Q3 of the weekly contest 363. Maximum number of alloys. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. I spent a long time on this problem, but to be honest, it doesn't really deserve it. It's not that bad. I mean, it's not that easy, but it's not that bad. Or at least not. I think my total time is like 20 something minutes on this one because I kind of skipped ahead. But the reason is just because I misread the problem, to be frank. And you could kind of watch the live portion, skipping forward until I think there is maybe I'll put a timer or a timestamp on the comments of like there's a moment where you see Larry go, "Oh wow, I misread the problem," and then and that part that I missed is that all alloys have to be created with one machine. So already it already reduces it to just a problem of checking each machine. I for some reason I missed this line for about 20 plus minutes, and then after that I got it pretty quickly, because I was thinking about some like weird dynamic programming problem because I thought that you can use multiple machines. So I just really misread this problem. So it's kind of sad, if you ask me, to be frank, because I was like, this is like a ridiculously hard problem, but I guess it's a lot. I guess it's a lot easier when you read the problem correctly, as the problem writer, intended. But yeah, so now this reduces to just solving it for each machine. You just do a loop to get the best one. And the way that I did it, and I think you can maybe kind of, I don't know. I think there may be like a way to kind of do it carefully, with like math and calculations and stuff like this. I think because this is like I don't know. There may be a easier way, or there may be a way to do it analytically. I didn't do it that way. Symbolically, maybe. The way that I did it is with binary search. So going to code really directly now. This part, like I said, we just try to calculate for each machine, calculate and figure out if that's the best machine to use and return the result, right? So this is pretty straightforward. This part is the kicking off the calculation on one machine, and of course you have the binary search. Let me actually double check really quickly how long that took. Okay, not really worried about 1.6 seconds, because I think I could do a little bit minor optimizations just in case it times out after the contest or something weird. But yeah, but this is binary search on the answer, and basically this is saying, okay, if I want to create X number of alloys, how much would it cost me, right? And that's basically really, and if we can create the mid number of alloys, then we're going to try to create, or we're going to try for a bigger number, right? Because we're trying to maximize. So if this is already good, then we'll try for a bigger number. That's what this means. And so this is why we expand. Otherwise, mid is not a possible answer. So we kind of, go to a smaller one. And the good function is just pretty straightforward. It's just calculate, okay, given this target, how much does it cost? Well, for this target, how many do we need per target? So this is what it's saying, how much we need per target, how much we already satisfied by having stocks, and then this is basically how much we still need after taking account the number of stock that we have, and then this is just the cost, right? Of course, we just do a max is greater than 0 so that we don't make a silly mistake with negative numbers. You have overstock, you don't get money back, right? So yeah, so that's basically the idea, and this will be the total. So this is the total cost to build target number of alloys, and we check to see if that's under our budget. That's pretty much it. What's the complexity here? This is O of n, or O of k, sorry, I guess there are a couple of variables here. This is O of k, this is O of log r, where r is the range of the numbers, something like this, or number of things that you can build. I probably overdid it, but I didn't want to think about the math, that's why. Because I think you could probably get a tighter bound on the upper bound, but like I said, I just didn't want to deal with it. Yeah. And And yeah, and this part is O of n. So in total, this is going to be O of k times O of n times O of log r, where r is the range, right? And you know, this is 100. This is 100. This is the way that I did it is, what did I do it? It was like 60 or something. So yeah, that's pretty much it. Binary search, brute force on each machine. Yeah. That's all I have for this one. Let me know what you think, and you can watch me solve it live during the contest next. So easy to make a mistake on that one. Okay. Okay. What are the constraints? The constraints are 100. Maybe not that big. All right. Let's see. Okay. It's cost. So many things. Okay. So you have n machines, or n metals, k machines. So the I is k and j is n. Okay. You have metals. Okay, and then the budget is pretty big. What am I doing here? So do we always only want to use one machine? I don't think so. Maybe. Do we ever use... No, there's an obvious thing to use multiple machines, right? Am I misunderstanding it? Like if stock is 100, and one requires 1 0 and the other one 0 1, then you can kind of create a lot of things, right? N and K is 100. What does that mean? Some combination of these things, right? N is the number of metals and K is the number of machines. How did someone already get this? 3 people already got this. I don't even understand the problem. It's definitely... I still don't even understand the problem. I mean, I understand the problem, but I don't understand how you even approach it. What is the budget? Budget could be 0, so yeah, okay. The cost does cost stuff, so nothing is free, which is fine. It's like some sort of weird matching thing. people are getting this though, so I feel like I'm maybe overthinking. There's also, unless I'm missing something. No. Okay, 100. I am struggling on this one. How do you? Is there a greedy aspect of it? No, not really. Is there DP? Is there a DP? The DP would be to use up the stock, right? But really don't know this one. Oh, this is the composition. Okay, so maybe I missed that part. Did I? Or does that matter? How is this a medium? What is the 0.5? What am I doing? Wow, people have already done. iWise is dominating. Skipped ahead. Maybe I should skip ahead real quick. This is too much work. No, I mean the later one should be okay. Let's just YOLO submit. I don't know if this is right. It is right. That's ridiculous. Alright, let's actually get back to this one. I don't even think I understand this one, to be honest. Square three things. I don't know that I can prove that. Alright, let's focus a little bit. Let's finish this and then call it a night. Is there a binary search? Maybe that's what I should have done. I didn't even think about it. What would a binary search even look like? What would a binary search look like? Can we create 5? I mean, apparently it should be easier. Oh, 578 people got it. I am not one of those people. People got it in like 3-4 minutes. I didn't even read the prompt that fast. But we probably would not create one at a time because budget is too high to do it one at a time. But we could probably do it one at a time to get the stock down, but the stock is high too, right? So maybe not. Can we convert the stock to money? and then do the math on the cheapness. No, that's greedy and silly. Right, because you can definitely lead to suboptimal things. Am I not reading this? I feel like N and K is 100. Is there a DP? How many machine can you want to do? I mean, my intuition is that maybe you ever only want 3 machines or something like this. Like you never. Oh wait, that doesn't make sense. You can have K machines, all used. Like if they're all 1,000 or something. Yeah, we can. If it all uses 1 at a time, then that would. Then what am I doing? Are able to get it quickly. I don't know. I mean, maybe it's just greedy and. Oh snap! Is what the? Wow. I mean, I know it's in bold, but I just read this now. Wow. Wow. Okay. Well, I am an idiot, clearly. Alright. Regroup. Okay, let's go. I am clearly an idiot, but we can. Let's talk about how much I'm an idiot after I solve this. Right. So what's N again? N is the. Okay, so we actually want K for the machine. Let's assume. Right. Oh my. Whatever. So how much would it cost? Right. So okay. Can we binary search? Do we want to binary search? Let's see if we could solve for just one of these, right? I am not smart. I am not smart. Let's just binary search. Oh my. I feel so dumb about this one right now. Is 15 even good enough? I don't know. Let's go for 20. I don't want to think about it. If what am I doing? I'm so tilted now. Just reading comprehension terrible. Okay, so this is good. Focus. We want to try something bigger. Else, and just return left, right? Let's just say target and mid. And target. Let's go index and mid. I was wondering why people got it so silly. Okay. Okay. So then now, if we want to have hit target, we need cost is equal to 0, and then for I in range of n for each of the metals, composition of I and of index and I, which is terrible. For that metal, we need, that's the number we need, time for each times target. Yep. And then we minus this by the stock of I, right? So that's how much we have, or that this is how much we need, and then this is how much we it costs. Oh, this is a terrible name. Okay, so okay, right. And of course we just want to make sure that this is 0 or more. And then we just want to make sure that this is less than budget. I am not a smart man. 252. Alright. Wow. I mean, this time. Wow. I can't believe I misread that problem for basically the entire time. I wasted so much time. So much time. Q4, I was. Thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.